Hello ladies and gentlemen, in this tutorial we'll talk about limits, and it's one of the most interesting topics that you're going to talk about. Okay, so I want you to keep it cool. Whatever we're going to talk about, just keep in your mind that it's very simple. Just make sure you think of it being simple, not being difficult, for you to enjoy what we are talking about today. Okay, so the first thing to know about limits is how to read the limits that you've been given. How do you do so? So suppose they say that as x approaches a certain number, let's call it c, then f of x is approaching a certain number which we're going to call L. Okay, so from this we've talked about here, we can say the limit as x approaches c of f of x is equal to L. That's how we're going to be reading the limits that we've been given. It's very simple. Now, what we're going to do to make it even more simpler, let's talk about the things which are mostly involved in the exams or in the questions that you're going to be calculating. And that is finite limits at infinity. Suppose you've been given f of x being equal to 1 over x. Okay, then they tell you to say that the limit x is approaching infinity. Maybe from the positive, from the negative, it is approaching infinity. So we can say negative or positive infinity over x. This one is very much applicable in a lot of questions that you're going to be doing. Moreover, the answer is just 0. You may think about it. When the denominator is becoming greater, the answer you will be getting is going to be very small. Suppose it is 10. That's going to be 1 divided by 10, which is going to give us what? 0.1. The more we increase this number, let's say it becomes 100, we're going to have 0.1. So the more it will be becoming smaller. So it's just thought of being equal to 0. This is very much important, and this is known as the limit at infinity, since the value of x is infinity. But the answer we're getting this side is a finite number. So we can say the limit is finite. Finite limit at infinity. What else? This is not the only one. You can also have a limit where x is approaching 0. Then you have 1 over x. This is equal to infinity. This is also very much important. This is the difference. This is the opposite of the one we have talked about. Let me give you an example. Suppose we choose a number which is very close to 0. What number is that? So let's choose 0.1. So that's going to be the limit of x as it approaches 0.1. Okay, then there we substitute 0.1. What are we going to get? In this case, we're going to get 10. The more this number becomes very smaller, the answer we're going to get will be increasing. Suppose it is 0.001. And what is this? This is very much important. This guy and this guy. And actually, this one is known as the limit, the infinite limit. Since this guy you're getting is infinite, so the limit will be infinite at finite or finity. What else? this is not the only thing you're supposed to know. You also talk about asymptotes. And they are very simple. Asymptotes. Okay, what about asymptotes? Suppose you have f of x, which is given by, we know that you're going to have the numerator on top, and then maybe the denominator that side. Now let's talk about the values of x. Suppose it is in terms of x, and the highest power of x is, let's call it p. Then on the denominator, the highest power of x, let's call it a. So the highest power of the numerator is p, and the highest power of the denominator is a. Okay, now from this guy, they can tell you to find the asymptotes. We'll start with the simplest one, vertical asymptote. Whenever they ask you to find vertical asymptote, you should be smiling. This one is very simple, just like the rest. What are we supposed to do? So, when finding the vertical asymptote, you just have to equate the denominator that you have being equal to 0. Then you look for the value of x. Just equate the denominator that you have being equal to 0. Then you look for the values of x. For example, if the function is, you have the numerator, then the denominator we say maybe it's, let's say this is 16. Then they tell you to find the vertical asymptote. We're just going to equate the denominator that we have being equal to 0. Then I look for the values of x. In this case, it's going to be positive and negative 4. Now, what does it mean when we say asymptote? This means you are getting closer to the line without touching it. Getting closer to the line without touching it or passing through it. Okay, that is the meaning of asymptotes. What else? There is also this asymptote which is known as a horizontal asymptote. Horizontal asymptote. It is also simple how to go about the question. So what are you supposed to do, or for you to know that the function that you've been given, it contains or it has the horizontal asymptote. It's not every function that you're going to be given which is going to have the horizontal asymptote or the vertical asymptote. For example, if this expression here, there was a positive, when it crosses the equal sign, we're going to have x squared being equal to negative 16. When we find the root, this guy is undefined, so we can say there is no vertical asymptote. But since it is negative here, this is working out. So it's not always that we're going to have the asymptotes. So let's talk about the horizontal asymptotes. For you to have the horizontal asymptote, the highest power of the numerator, which we are saying p, should be equal to the highest power of the denominator. So p should be equal to a. Now what are we really talking about here? Let's do an example. Suppose you have a function 5x raised to the power 3 and plus 2 x squared minus 3 of 2x plus 3x raised to the power 3. Okay, so the highest power, that is the power of the highest degree, that is the power of x in this case. So we have seen that 2 is not the highest power because we also have x which is raised to the power 3. So 3 in this case is the highest power. And we can see that Even the denominator is having the highest power, which is 3. So in this case, there is the horizontal asymptote. And what are you supposed to do? You're just going to multiply the denominator in the numerator by 1 over x cube, which is the highest power. So if the highest power was 2, we could have multiplied by 1 over x raised to the power 2. As simple as that. Then whatever happens to the numerator also happens to the denominator, so we'll do the same thing. Okay, so working on this, what we're going to end up with is just going to erase what I have here. Okay, so doing the calculation there, what are we going to get? Just take it easy. Know that these things are simple. So we're going to multiply 1 times 5, which is 5, then over x raised to the power 3. So the x cube, they're going to cancel. I'm just going to have 5. The next one, 2 x's, they'll cancel with the, meaning the denominator, we're just going to have 1x there. And this side will have 3. Since there is no x cancelling, there will be raised to the power 3. Then the denominator, doing the same thing. Here I'm going to have 2 over x squared plus, this will just be 3. Now, the limit's supposed to be approaching infinity. It's supposed to be approaching infinity. So if it is approaching infinity, we can say that as x approaches infinity, and don't worry, you're going to be told that this is approaching infinity. Three plus 2x cube. Okay, so we have as a, okay, now we said when you have 1 over x from this guy, 1 over x, then you are substituting the infinity and becomes your denominator. The expression is just going to be 0. So this guy is 0, even this one is 0, even this one is 0. So the final answer is just going to be 5 over 3. Now, when it's a multiple choice question, no need of doing all these calculations. When you've been taught to find the horizontal asymptote and you found that the highest degrees of the numerator and denominator, they are the same, just get their coefficient. The final answer is just their coefficient. The coefficient of this is 5 and the coefficient of this guy is 3. That is the final answer. That's how to go about it in a more quick way. Now these are the only asymptotes we'll be talking about. There is the last one, and it's actually very simple. Going to do a question about it and how to find it. Okay, the last one is known as the slant asymptote, which is also known as oblique asymptote. So this one comes in when the highest power of the numerator is greater than that of the denominator. Now, for better understanding, we'll do a question about this one. Okay, so what else are you supposed to know? You should also know the special trigonometric limits. They are actually very simple and just one that you're going to be using in this semester too. There are 2 in the lecture slide, but you're going to be using the first one much often in the Second one, you're not going to use it. Maybe you may use it once, but in our intake, we never even used it. And I've been seeing some papers, they don't use it. But we'll talk about it just in case of cases. Okay, so we're saying trig, special trig, limits. So the first one is when you have a limit and x is approaching any number, which we can say maybe c, then sine x over x is equal to 1. Whenever you have sine, then what follows after the sine, the angle that you have, is the same angle you're dividing by. Then this is equal to 1. The number you're dividing up is equal to the denominator, and this is equal to 1. So even though we multiply this by n, we say sine n, then we divide by x. This is not equal to 1 because this guy and this guy, they're different. For it to be 1, this guy is supposed to be n as well. This is the first one, and this one is the one you're going to be using a lot. Then the last one, as x approaches n variable, 1 minus cos x over x. This is equal to 0. Okay, so just make sure this guy and this guy, they are the same. Then it will be equal to 0. That's all about the special trig limits. Then we're going to do questions which are involving the same limits. Looking at the example that we have there, let me just erase. We can see that when we substitute 1 direct in this expression, the 0 in the denominator will become 0 as well. This form is known as indeterminate form, and whenever you have this indeterminate form by direct substitution, then you gotta do something else to the thing that you have there. We're supposed to factorize it or maybe multiply by the conjugate. So in this case, we can see that we can factorize what we have on top here. That is by finding the product, sum, and factors. So the product is -2, sum is 1, factors, that is going to be 1 and 2. And 1 supposed to be negative. So this is actually going to be equal to x plus 1 plus 2, getting this guy, and x minus 1. Then over what I have here, I can factorize x so that I have inside the brackets x, then minus 1. This guy and this guy just going to cancel, and we'll end up with x plus 2 over x. Then substituting 1 direct, now this one can work. 1 plus 2, that is 3 over 1. So the final answer is just 3. Okay. What about this one? This one, we can see that when we substitute 0 direct in this expression, we're going to have the indeterminate form. Indeterminate, not undefined, but it's indeterminate. So we have to do something else. We can't factorize what we have here. So in that case, we're going to find the conjugate. So take note, when you have the indeterminate form, you can't factorize, then find the conjugate. If you can factorize, factorize. Okay, so this is x raised to the power 2, then we have 100 here. Minus 10, and this x squared. What are you going to do? You're going to multiply the numerator that you have, conjugate. So this times 100 minus 10. Now since it's a conjugate, we're going to put a positive 10 and over the same guy. What happens to the denominator or the numerator should be exact. Same thing happening to the other. Okay, so let's do the multiplication. You take it easy. Know that it's very simple. We're just more like breaking. It's a puzzle. Okay, so when you're multiplying two conjugates, just multiply direct. This guy in this one in this one. We talked about this in complex. So let's do that. And whenever you are multiplying the roots of certain numbers and they are the same numbers, the answer is just equal to the same number. And we can see that this guy and this guy, they are the same. So we're just going to have x squared plus 100. Then negative 10 times 10, that is negative 100. Then the denominator is going to be x squared multiplied by x squared plus 100 and plus 10. Okay, so this one and this one, that is 0. This one and this one. Okay, so this just means that the limit as x approaches 0, the numerator is just 1. They cancelled. In the numerator, the denominator that we have is x squared plus 100 plus 10. Okay, so when we substitute 0, this is going to be 0. Then the root of 100, that is 10. 10 plus 10, that is 20. Just like that. So the questions, they are very simple. Then let us look at the asymptotes that we talked about. Do you still remember what we talked about, the slant asymptotes? The slant asymptotes, we said the degree of the numerator is supposed to be greater of that of the denominator. And that of when talking about the horizontal, is supposed to be equal. In this guy, you just equate the denominator being equal to 0. So let's see the examples that we have. This one, find the oblique asymptote, which is also known as the slant asymptote. So for you, you're supposed to determine, is the degree, the highest degree of the numerator greater? Yes, because here you have 1. Then you can find the slant asymptote. So you have 5, you have 7x plus 4. Then we're dividing into 2x squared. Putting all the terms, we should also put 0x, which is raised to the power 1, then minus 3. Let's start dividing. What is 2x squared divided by 7x? That is 2x over 7. Multiply the same answer you have gotten times 7. That is 2x squared. Again times 4. We're going to have 8x over 7. What else? From there, you're going to subtract what you have this side. This expression is just going to give you 0. When you subtract here, that's going to give you negative 8x over 7. Then again, you divide this expression, negative 8x over 7 divided by this guy. This is going to give you negative 8 over 49. When you multiply, it will still give you back this expression over 7. Then again, this expression times 4. So it will be negative 8 times 4, giving us 2 over 49. Then we drop the 3, comes here. What are you going to do next? You subtract. Okay, so this side is going to give you 0. And this side, when you subtract, you're going to get negative 115 over 49. Okay, now which one is the slant asymptote? It's actually in number, an equation in terms of x, this guy here. Over 49. By doing so, you are done. Okay, let's go to the next one. This one here. Find the horizontal asymptote and vertical asymptote of the graph. So this is the graph that we have here. Keep it cool, simple. When finding the horizontal asymptote, we said the degree of the numerator is supposed to be equal to that of the denominator. But we can see that 8 is more like 8x raised to the power 0. This is just equal to 1, so we haven't changed anything. Okay, so the degree of the numerator is less. They are not equal. So this guy is not there. It doesn't exist. It's not there in this graph. What about the vertical asymptote? Very simple. Just going to equate the denominator that you have being equal to what? 0. Then you work on this, is going to give you positive or negative 2. That's how simple it is. In this limit, you've seen that the powers, that of the numerator and denominator, they are equal. So that means that you're going to have the horizontal asymptote. In this case, we say they're just the coefficient of the highest power. And you're done. That is 5 over 3. Then what about these guys? These guys, they are also simple. So this one is saying x is approaching 1 from the positive, which means numbers that are greater than 1. So you can choose 1.999 or you can even choose 2. Now, when this is happening, what do you think will be happening to the denominator? When we substitute as x approaches 1, it becomes very close to 1. We know that it's going to be positive because we're saying from numbers that are greater than 1. So the denominator is going to be positive. But what we'll be getting here will be very small. And we said when the denominator is very small, then the answer you're going to be getting is infinity. And when it's very big, the answer you're going to be getting is 0. Don't forget. What about this one here? You are approaching from numbers that are less than 1. So you can choose maybe to know if it's going to be positive or negative. You can even choose 0. But and it's not like you're going to show them that you have chosen this number now. So you can choose 0.9999999. When I substitute this number in this, it's going to be a negative and a very small number. That's what I'm going to get. Then we also talked about sign, limits of trig functions, and we said it's very simple as well. Take note, I told you that this one, no matter where you go, no matter what you'll be doing this semester, always remember, when you have sine nx and the expression that you have as your denominator is the same as what you have here, then this is equal to what? So now that is equal to 1. Let's solve the questions that we have. Take it easy. Okay, looking at the first question, there is nothing as approaching from numbers that are greater or numbers that are less. So just go direct substitution. So what are we going to do here? We're going to just substitute pi over 4. And this is equal to 45. So if you never watched where we talked about special angles, sine 45, sine 60, sine 90, what are they giving us? Then make sure you watch the video about the complex numbers. Okay, so sine pi over 4 is just equal to 45. That's very simple because 180 is equal to pi. So you can substitute 180 there. It's going to give you 45. It will be 180 divided by 4. It's going to give you 45. And sine 45 is equal to the root of 2 over 2. Very simple. You move on to the next one. Take it easy. You're not kidding anyone. This one here. It is also simple. The limit as x approaches pi. So even this one is just direct. You're going to substitute direct in the expression that you have. You're going to substitute pi. Even here we substitute pi raised to the power 2. So definitely we're going to have negative 1 over pi squared, because cos 180 is a negative 1. Okay, and keep in mind you're not going to be using calculators. Then this one is also simple. What are you going to do there? What you're going to do is actually you're going to find the common factor. We know that tan is this side and this side. And 2 can go into 8. It can also go into 2. So you're going to factor out tan x2, which is 2 tan x. Then factoring out, this side you're going to have 4x. Then this side you're going to have just pi divided by 4x pi. This guy and this guy are going to cancel. And finally, we're going to substitute 45 degrees here, which is just equal to 2 times 1. This expression is 1. And 45 is 1. The final answer is going to give us 2. This is how simple the questions are. But you've seen we haven't applied the special limit. It is mostly applicable, and you're going to see the question we're going to be applying it. For example, these questions, that's where you're going to apply the limit now. Okay, so you have cos squared x, then over sine over 1. When you substitute 90, cos 90 is 0, sine 90 is 1, raised to the power 2, that is 1 minus 1. So this is going to give us 0 over 0. This is indeterminate. And remember, indeterminate, that's not the form we're looking for. So we're going to do something else to this equation to make it work. Okay, since we can't factorize that with what we have on top there, what we can do is this. Sine squared x plus cos squared x. This is the common identity one should know this semester. This is equal to 1, making cos squared x or sine squared x minus 1 the subject. This guy crosses the equal sign. Then cos, when it crosses the equal sign, is going to be negative. Okay, so this expression is what we're seeing here, which is just equal to negative cos squared x. Substituting this guy, they're going to cancel. The final answer is just going to be equal to 1. Very simple. And also, let's try the last one, the second one. Okay, so the second one, that's where we have to apply the special limit. So the more you're going to do these questions, you can even just look at the question and you can tell that this one I'm going to apply the special limit, this one I'm not going to apply. Just continue solving a lot of questions. You've seen this guy and this guy, they're slightly the same, but for this one to be equal to this one, we have to multiply by 2. So what we're going to do, we'll multiply this by 2 by 2. Remember, we said sine x over x. What we have here is supposed to be exactly the same as the denominator. So when we multiply, we're going to have 2 sine 2x minus 2, then over, when we multiply this guy, we're going to have 2x minus 2. Not so. And this is working out as the special limit. So this expression is just equal to 1. 1 times 2, that is equal to 2. So most of the time you're going to be multiplying the denominator and the numerator by a number, which is making it possible for you to apply the special limit. Okay. Look at this question. It is also simple. Limit as x approaches 0. So you have sine x over sine 2x. These guys, they can't cancel. And when you substitute 0, you're going to have 0 over 0. This is indeterminate. So you have to do something else to this expression. What are we going to do? You don't have any identity to this guy. This one we have an identity, but no, we're not going to apply it. We're going to apply the special limit. That is, we'll say the limit as x approaches 0, sine x divided by, this is just the same, sine 2x. Now I want the denominator, this guy, to be x. I want the denominator to be x, so that I have the special limit. So what I'll do is I'll multiply this side by x. Again, what happens to the numerator also happens to the denominator. This side is more like you just have 1 divided by. Even this guy, I want its denominator to be 2x. So I'll multiply this side by 2x, even this side by 2x. Then from there, I'll take the 2x, comes sit here. Again, x comes sit here. So 1 times 2x, 1 times x. So we'll definitely end up with sine x over x multiplied by x divided by sine 2x over 2x multiplied by 2x. Okay, so this expression is 1, even this expression is 1. So you just end up with x then divided by, this is 1 times 2x. This guy and this guy, they're going to cancel, so your final answer is just half. You're done, just like that. How to apply the concept is very simple. Okay, so the Babkolo Babantu, apply the same concept to the other questions. When you solve, I'm free in the inbox, you can inbox me and we talk about it. Okay. So from this tutorial, we'll talk about continuity and to finish up the special limits, that is the log and the exponentials. But they are very simple, and mostly you're going to be facing the trig limits. The Babkolo Babantu Bamunaka Bapromoter. So if you want to join us on WhatsApp, you can contact me on 0968 0052 11, where we interact from. Zuibo dude.